everybody, my name is Bruce. In the next 3 lessons, I will be performing a series of chemical experiments to allow us to identify the presence of certain ions in solutions of ionic salts. We will record all our observations for the experiments and write down balanced chemical equations so that we can understand the chemistry behind these identification tests. Before we carry on with today's lesson, let's remind ourselves about the concept of an ionic salt. An ionic salt is a chemical substance that is made up of cations and anions. Cations are positively charged ions and anions are negatively charged ions. We will start by looking at chemical tests that will allow us to identify what anions are present in solution. In this lesson, we will specifically be looking to identify halogen anions. These are known as the halides, and this is the general name given to the ionic salts of all group 7 elements. Before we do that, let's look at the outcomes for this lesson. By the end of this lesson, you should be able to recall the identification tests for specific halide anions, recognize the observation for each specific test, draw conclusions as to what anions are present in the solution, and write balanced chemical equations to explain the chemistry of identification tests. Let's now take a closer look at the group 7 halogens. To assist us in using the correct terminology, here are the names of the group 7 halogens when they are chemically bonded to form halides. Fluorine becomes fluoride, chlorine becomes chloride, bromine becomes bromide, and iodine becomes iodide. We will be using solutions of sodium chloride, sodium bromide, and sodium iodide to perform tests to identify the presence of halide ions in solution. Please note that we will not be using any fluoride ions at all. This is because fluorine is very reactive and far too dangerous to use in this environment. We need to place a little of each halide in a test tube and then add a few drops of the solution silver nitrate to each test tube. After a few minutes, add a few drops of nitric acid to each test tube. Look carefully at what happens in each of the test tubes and take note of what you see. In each case, a discoloration was observed. This was due to the formation of a precipitate. Can you see how the color of each precipitate varies? The precipitate did not react when nitric acid was added. That is to say that the precipitate is insoluble in acid. I've drawn up a table of results. Compare your table with mine. In the test tube containing the chloride, the precipitate is white. In the test tube containing bromide, a cream-colored precipitate is formed, while in the test tube containing the iodide, the color of the precipitate is yellow. None of the precipitates reacted with nitric acid. The formation of these precipitates when silver nitrate is added to the solution gives us a way of testing for the presence of halide ions. In other words, we can make the following conclusions. Precipitates will only form if silver nitrate is added to a halide solution. The precipitate is insoluble in nitric acid, and the color of the precipitate tells us which halide ion is present in the solution. Let us now summarize everything so far. Silver nitrate is used to identify halides. Chlorides form white precipitates, bromides form cream precipitates, iodides form yellow precipitates with silver nitrate. The precipitates are all insoluble in nitric acid. So now we have developed a test to identify the presence of halide ions in solution. What we now need to do is explain the chemistry by having a look at a chemical equation. I will look at the reaction between sodium chloride and silver nitrate first. First, let's see what happened when the substances dissolved in water. Well, they will form ions. Remember, we indicate the phase of each substance using these subscripts. The symbol S indicates that the salt was originally in the solid state before being dissolved, while the letters AQ, standing for aqueous, tell us that these ions are now dissolved in water. Now let's see what happens when we add these solutions together, more specifically the interactions of these ions. The ions are all in the same beaker and can move freely in the solution. The positively charged cations are able to attract the negatively charged anions. When the silver cation attracts the chloride anion, an insoluble product known as silver chloride is the precipitate that forms. The other ions remain in solution as soluble ions. This is what the completed equation for this reaction would look like. The aqueous sodium chloride solution reacts with the aqueous silver nitrate solution to give us our solid silver chloride precipitate, while the sodium nitrate remains in aqueous solution. In this reaction, both the solutions contain ions, and the ions were swapped around. In other words, the sodium started with the chloride and ended up with the nitrate, and the silver started with the nitrate and ended up with the chloride. This is what we call an ion exchange reaction. Let's learn that. An ion exchange reaction is a chemical reaction where the ions are swapped around in the reaction to give two new products. Now let's write equations for the other two reactions, namely for the bromide and the iodide salts. Note carefully how the ions have swapped around in each of these reactions. Here we can see that sodium bromide will react with silver nitrate to form our precipitate of silver bromide and our aqueous solution of sodium nitrate. In our second equation, sodium iodide will react with silver nitrate to form our precipitate of silver iodide and our aqueous sodium nitrate. So far in this lesson, we have learnt about the test to identify the presence of chloride, bromide, and iodide ions in solution, and how to tell the difference between them. These tests are extremely sensitive. Only a small amount of chloride ions in solution will turn the solution milky if silver nitrate is added. And we only need to add a small drop of silver nitrate to see this positive result. What you may be wondering is why we have to add nitric acid to the solution containing the silver precipitates to ensure that the halide ion is present. I will now show you an important experiment that will explain this phenomenon. In this beaker, we have a solution of a sodium salt. The anion is unknown. Let's do the halide test to see if a halide is present. We add a drop of silver nitrate to the solution, and what do you see? A white precipitate. Now add a few drops of nitric acid. Look at what happens. The precipitate fizzes and produces bubbles and then dissolves. So we can conclude that a chloride was not present. What was the precipitate that was formed, and why did it dissolve in the acid? Well, the answer to these questions lie in the solubility rules from the previous lesson. Right, let's start off by writing down the ions that we know that are present in the solution. We know that there are sodium ions, there are silver ions, there are nitrate ions, and there's an unknown ion which I'll represent with a question mark. Well, we know that sodium nitrate will not form a precipitate, since we know that the solubility rules of all nitrates, and I'll bring this into camera, that rule number 1 says all nitrates are soluble, and also rule number 3 is that all group 1 metals and ammonium salts are also soluble. This means that the precipitate must be a silver salt. Now let's check the table again. What silver salts are insoluble apart from the halides? Well, they must be silver carbonate, because if we look at rule number 2, all carbonates are insoluble except carbonates of group 1 metals and ammonium. So that will confirm that it must be silver carbonate, whose formula is Ag2CO3. Now, when the acid is added to any carbonate, it produces bubbles of carbon dioxide gas. The carbonates will dissolve in acid. That is why the second part of the halide test is so important. We need to test whether the precipitate will react with the acid to distinguish between the halide and the carbonate. Let us now summarize everything that we have learned today. Silver nitrate added to a chloride, bromide or iodide solution will produce an insoluble precipitate. Silver chloride is a white precipitate, silver bromide is a cream precipitate, and silver iodide is a yellow precipitate. They are all examples of ion exchange reactions. The precipitates formed by adding silver nitrate solution to a halide solution are not soluble in acid. Please join me for the next lesson, where you will learn about detecting the presence of sulfate and carbonate anions in solution. See you then.
Yeah.